given that, practically everyone's carrying a mobile phone these days, or
Mm-hmm.
they're wearing wearables or smartwatches at any given point of
Yep.
time. And most of these devices, if not all of them, have some form of accelerometer, some form
Yep.
of controls that help you understand space, time, velocity, and so on and so forth, right?
Yep.
Because your Apple Watch just automatically pings you and says, "Hey, are you going for a walk?" or "Hey, I think you're cycling," and so on and so forth, right? And I think that's a combination of one, speed, and second, the motion or the path that your wrist, which is where the watch is taking, right? It's different when you're cycling, it's different when you're walking, different when you're running. Just curious to know, has anybody tried to try and collect, this sort of physics data from wearables, smartwatches, etc., to try and train robots? I mean, I would imagine that someone like Apple probably wouldn't give you that data. They'd in fact use it internally for any robotics development that they wanted to do. But if you take any of the others, right, or you even take a smartphone manufacturer because they have an accelerometer on it, right, and you can still at least, I don't know, count steps, etc., on your phone, even if it's in your pocket. So just trying to get a sense, has anybody collected this form of data, tried to collect this form of data to help train models? It's a very random question from my side, but it just struck me while you were talking about this.
Yeah, I think I don't know off the top of my head if anyone has tried collecting this data. I'm sure all the wearable companies are recording as much of and keeping as much of the data as they can.
Right.
I I'm trying to think. I don't I think people have tried to use that data to do things like localization, like figure out where you are and
I
stuff
see.
like that. Like I've heard of random research that has tried to like even do things like so your phone can give you a GPS signal so you know where that person is, but GPS has some accuracy. I forget. I think it's like maybe something like 10 meters or something. I forget
Uh-huh, uh-huh.
exactly how much it is, but um, people have done stuff like using like the strength of your Wi-Fi connection and the accelerometer and other IMU readings and things like that from your phone to get very precise locations of like up to a few centimeters of where you are in your house, right? So I mean, they're kind of privacy evading perhaps, but yeah, so there's been stuff like that. I think the value of I haven't seen a lot of people use or think about using that data for robotics. Um, I'll have to think a bit more. I can't say for sure if it's
Sure,
useful or not useful,
sure.
but I think the main problem is that it's again goes back to that kind of data will give you physics information, sure, but physics is something that's like low dimensional and easy to optimize, right? Sorry, not easy to optimize. I mean easy to explore or easy to sample from,
Hmm.
whereas or easy to randomize. Whereas images is actually the harder part. That's harder to optimize, harder to randomize and collect a lot of variety. So I think um, this large scale data collection is something that um, is most useful for number one, images, and number two, actions. So very, very fine grained actions. The problem I think
Understood.
with like wearables and stuff like that, maybe at some point smartwatches and maybe VR goggles, VR headsets might give us that, but if we could get really accurate action information, so like
Uh-huh,
when you
uh-huh.
pick up a phone, how exactly do you position your fingers, how much force do you apply, stuff like that. That's something you wouldn't really get it with a smartwatch or your smartphone.
Sure,
But
sure.
maybe if eventually enough people start using VR headsets, then and your hands are visible, then that's
Right.
something we can capture,
That could
right?
be very, very
Yeah.
got it.
But that's exactly those are the kinds of questions that we are trying to ask right now is what are what are the different, like, it's a very creative space. It's a very creative time where people are trying to figure out, hey, like, what are the different points in the pyramid, right? So as I was saying, like, bottom of the pyramid is videos, random YouTube videos. Top of the pyramid is teleoperation. And then in the middle you have so many different things. Like, you have egocentric video, which is like literally someone wearing a VR headset doing some actions. So you have
Right.
video from their point of view
Point
with
of
their
view. First person
um
view.
exactly, with their and you can look at their fingers and hands and infer what actions they are doing, but you don't have any force information. Then there's also, there are some companies doing in the industry, it's called UMI, UMI,
Okay.
hand. I forget what does it stand for. Let me look this up. UMI. Um, I think universal manipulation interface. That's right. So basically, it's a fancy term, but basically what it means is you you create, like, whatever your robot hand is, you create a replica of that hand and you make it like a glove, right? And then you use that glove to, like, when the humans are out there collecting, excuse me, collecting some data, you actually go out there and, like, collect data with that glove. And the advantage of doing that with, as opposed to using a human hand, is that your robot's hand is obviously different from your
Sure.
human hand. It has different, like, degrees of freedom, how much you can move and stuff like that.
Right.
So if you get the information of your robot hand doing it, then it's much more representative of what you'll actually run on the robot.
Sure.
So
Sure.
that's like higher up on the pyramid. But then
Plus,
it's it's
you can get force and pressure data as well,
exactly,
because you can have sensors on the view.
exactly. Yeah,
So
so that's again higher up on the pyramid, but again, it's like more expensive than YouTube data, obviously.
sure,
Or it's more expensive than egocentric videos also, because you actually need to make these sensors and hardware and give it to people. But yeah, there's like so much space in this pyramid. Like, people are spending a lot of time coming up with creative trade-offs, which are
interesting,
cheap,
very interesting.
scalable. Um, so yeah, I think the answer to your main question is endless simulated data. I think we, in a sense, we are there.
Hmm. Hmm.
Can endless simulated realistic data? I don't think we are there.
Yeah,
But I think this it seems like, yeah, not a lot of people are betting on getting endless realistic simulated data, but people do seem to be betting a lot on this pyramid approach.
sure, sure.
Which again, we don't know if it'll work, but there seems to be enough evidence that it is scaling up. But maybe if this doesn't end up working, then yeah, I could see people working, going back to, like, uh, endless simulated realistic data.
Understood. Understood. And maybe just one last question here. Do we
Mhm.
have the equivalent of a Scale AI or a Mercor for robotics? Is that something that you've seen? Like, are there companies that have offices full of people wearing those gloves, touching everything from grass to something delicate like an egg, right? Or doing fine tasks like trying to thread a needle and so on and so forth, or handle a screwdriver, right? Is that a thing that you've seen, become a part of the training infrastructure and training capabilities?
Yeah, I think a lot of these, like, I know Scale AI, and a lot of these companies that have data operations already, they are trying to kind of also get into robotics. Um, I don't think there's any big established players yet. Because the issue also is that, or the challenge is that, a lot of these needs are still very niche, or still used to be niche. They're getting more standardized now. So most robotics companies actually would end up collecting and annotating and building all this infra themselves. So that's what Figure does. That's what a lot of other companies also do. Um, Rather, most other robotics companies still do. But I've seen recently, as I was kind of alluding to this earlier when I said that, there's like in every conceivable space, there are in this whole robotics ecosystem, there are companies popping up. So one company or one type of company I've seen um, is people they ship these like cameras or VR headsets and stuff like that to lower income regions, like especially in Asia. And they have people collect a lot of data, just like doing some kind of factory work or manual work, like folding clothes and things like that. And they sell this data at pretty high margins to robotics companies and in like Silicon Valley or elsewhere. And um, again, like that's just one example, but there is like just collecting that data and then like doing quality checks, diversity checks, labeling services. I think, yeah, there are the market is very fragmented, is what I'll say. Like there's no, even in the LLM space, from what I'm not very familiar with the LLM space, but from what I've heard, it Scale AI, of course, is a major player, but even there, I think the market is quite fragmented from what I've heard. But in robotics, it's extremely fragmented right now, and I think part of the reason is just like a lot of the needs used to be niche, but
Right.
if and when this pyramid gets like standardized,
Uh-huh. Uh-huh.
then we could see more and more players emerging.
Very
But
true.
for now, it's still very fragmented and very lot of in-house solutions and stuff like that.